Hello everyone, welcome to the chemistry guide. Today we will learn how to draw a resonance structures. I am taking benzene structure. In this benzene, pi electrons are continuously moving inside this benzene structure. This shifting of pi electrons is known as resonance. So, resonance is the possibility of shifting pi electrons inside a molecule. How these pi electrons are moved inside the benzene ring? Well, it is due to electrons delocalization in pi bonds. Hence, we will learn the complete concept of electrons delocalization in pi bond. Consider this compound. There is one double bond between first and second carbons. We know that in every double bond, one is sigma bond and one is pi bond. Now observe carefully. In pi bond, electrons are loosely held between atoms and move freely. These freely moving electrons are known as delocalized electrons. We have learned that electrons are loosely held in pi bonds and they move freely inside the molecule. Now again consider the benzene structure. We know that there are alternative double and single bond present in a benzene structure. So this is pi bond and this is second pi bond and this is third pi bond. Now why electrons are moving inside this benzene structure? Well, there are pi bonds are present and pi electrons are loosely held in pi bonds, due to which electrons freely move inside the benzene structure. So very important point is electrons are moving freely in a compound if there is pi bond. Next, what is resonance structure? Consider this compound. Here very important rule which is you must remember, pi bond is equal to pi electrons. Here this is pi bond or pi electrons between first and second carbon. We have already learned that pi electrons are moved freely. Now at the third carbon there is positive charge or vacant orbit. Also remember this rule, if there is positive charge, it is also known as vacant orbital. There is possibility that the pi electrons shift from first carbon to third carbon. This possibility of shifting of electrons from one atom to another atom is known as resonance. Now, these pi electrons are shift from first carbon to third carbon, we will get another structure. Now, here first carbon has loosed one pair of electron, so positive charge will be appear on it. While this third carbon is get electrons, so negative charge will appear on it. Remember that this second carbon has neither gained nor loosed any electrons. So it remains as it is. Now this structure and these structures are known as resonance structures. Next, possibility of resonance structures. Resonance is possible if there is pi, sigma and lone pair of electrons are present. For example, consider this molecule. Here this is pi bond, sigma bond and lone pair of electrons are here. So resonance is possible. Secondly, resonance is possible if there is pi, sigma and free radical. For example, this is pi bond, this is sigma bond and this is free radical. Thirdly, resonance is possible if there is pi, sigma and vacant orbital. For example, consider this molecule. Here, this is pi bond, this is sigma bond and this positive sign means vacant orbital. Firstly, we will learn resonance structures of linear geometry. I divided them into two types, type 1 and type 2. For type 1, I write need electrons. For type 2, I write don't need electrons. Now consider this example. We already know that there is pi electrons are present in this pi bond, while this positive sign means that this carbon needs electrons. Hence, electrons will shift from first carbon to third carbon. We get this structure. Remember that when I shift electrons, I shift double bond also. So first carbon lose electron plus charge appear on it. Third carbon has gained electrons, so its empty orbit is completed. Now what about the hybrid structure? Well, I write here CH2 single bond CH single bond CH2. Double bond is present here in this structure and double bond is present here in this structure. So I draw dots here and here also. These dots represent the formation of double bonds between atoms. The positive charge is appear here in this structure and here in this structure. So I write positive charge here and here. So I get two resonance structures of this compound. Remember that hybrid structure is complete or real structure of any molecule. Well, resonance structures are imaginary structures. Now, let's consider this molecule. Here, this dot means free radical or this carbon has one electron. It needs more one electron. Now, there are pi electrons are present here. So, this pi electron will shift here. I get this structure. Here, one electron is remaining on this first carbon and it is represented as dot or free radical. For hybrid structure, I write CH2 single bond CH single bond CH2. Now, double bond may be here or may be here. The free radical may be here or here. So, these are two resonance structures of this compound. Thirdly, consider this structure. This positive sign means that it needs electron. There are pi electrons are present in this pi bond. Pi electrons will shift here to this carbon. I get this structure. Electrons is loosed by third carbon. So positive charge appear on third carbon. Also we can see that there is possibility that this pi electrons shift to this vacant orbital. So I get this structure. Here electrons are shifted from first carbon to third carbon. So positive charge appears on first carbon. Now the hybrid structure of this compound, there is double bond present here, here, here and here. Positive charge is on the first carbon, third carbon and fifth carbon. There are total 3 resonance structure of this molecule. Now let us see the type 2. We know that they don't need electrons. For example, I consider this molecule. Remember that these 2 dots means that oxygen has one lone pair of electrons. It doesn't need any electrons. Electrons will shift here. Also these pi electrons will shift to this carbon. I get this structure. Now this oxygen has loosed these electrons. Positive charge appear on it. This carbon gained electrons. So negative charge appear on this carbon. For hybrid structure, I draw CH2 single bond CH single bond OH. There is double bond present here and present here. The positive charge is present on this oxygen and the negative charge on this first carbon. Overall positive charge and negative charge cancel each other and this molecule is a neutral molecule. So using these 2 tricks, we can easily draw resonance structures of molecules having linear geometry. Now we will learn resonance structure of trigonal geometry. Consider this carbonate ion. Remember that when oxygen forms single bond, it has 3 lone pair of electrons and the negative charge will present. If oxygen form double bond, it has 2 lone pair of electrons and it has no negative or positive charge. In case of carbonate ion, carbon is double bonded to first oxygen and single bonded to second and third oxygen. Here oxygen is double bonded, so it has 2 lone pair of electrons. Here oxygen is single bonded, so it has 3 lone pair of electrons and negative charge. Also, this oxygen has 3 lone pair of electrons and negative charge. Now, I will use one trick here. I rotate this structure in 90 degrees and reflect in the mirror. When I rotate 90 degrees clockwise, this oxygen will come here and this oxygen will come here and this oxygen will come here. So I get this structure. Secondly, I place the mirror in front of this structure. This oxygen will be here and this oxygen will be here. After reflection, I get this structure. So there are 3 resonance structures of carbonate ion. Now, what about hybrid structure? We know that double bond is present here, here and here. Also, we know that the net charge of carbonate ion is -2. We secondly consider nitrate ion. We know that this oxygen is double bonded to nitrogen, so it has 2 lone pair of electrons, and these 2 oxygens are single bonded to nitrogen, so they have 3 lone pair of electrons and negative charge. Remember that when nitrogen forms 4 bonds, positive charge appear on it. Now I will rotate this by 90 degrees clockwise. This oxygen will be come here and this oxygen will be come here and this oxygen will be come here. I get this structure. Secondly, I place mirror in front of this structure. This oxygen will be here and this oxygen will be here. After reflection, I get this structure. So, these are 3 resonance structures of nitrate ion. Now, let's see the hybrid structure. Double bond are present here, here and here. We know the net charge on nitrate ion is -1. Now consider this molecule. I rotate it 90 degrees clockwise, so I get this structure. Secondly, I place the mirror in front of this structure. After reflection, I get this structure. So, there are 3 resonance structure of this molecule. Now, to draw its hybrid structure, double bond is present each side. The net charge is positive on this molecule. So, using this trick, we can easily draw the resonance structures of molecules. Also remember that there are some exceptional cases like ozone. Here we do not rotate it, rather we just reflect it. After reflection, we get this structure. Now let's see its hybrid structure. Well, we can easily draw its hybrid structure like this. Double bond is present here and here. So, hybrid structure of ozone is like this.